Okay, before we talk about the pH scale, one of the other term that we have to define is what's called an amphoteric substance. Okay, amphoteric is something that can act as either an acid or a base, depending on what it's mixed with. And the most common examples are water and the hydrogen sulfate ion. Just to show you in this chemical reaction, here's the acid, and you have water acting as the base that's going to accept the hydrogen ion. And then in this substance, here is ammonia. So here is a base, and you have water acting as an acid that this time is going to donate its hydrogen ion. Okay, so particularly because water has both hydrogen hydroxide in it, it can act as either one, and that comes in handy. So that's what's called an amphoteric substance. Okay, the pH scale is the strength of an acid or base solution, and what it refers to is the concentration, which is defined by these brackets, of hydrogen ion. Numbers of hydrogen ion concentration can be very small, so we developed the pH scale using a log scale, and we'll talk about the math here in just a little bit. It's a scale from 0 to 14. Values beyond the scale do exist for very strong acids or for very strong bases. We won't work with them very often, but you can have negative values and you can have greater than 14 for those very strong situations. And one thing to note is that pH and hydrogen ion are inversely related. So the higher your hydrogen ion concentration is, actually the lower your pH is. And that has to do with the math and the whole log-based scale setup, but that is going to be an inverse or directly related. It's a very frequently confused term for people. Now for the pH scale, like I said, there are some negative values that are off the charts, but 0 to 7 is typically acidic, so anything less than 7 is going to be an acidic. Notice we give you that red again to indicate that with pH paper it typically turns pH paper red. Right at 7 you have our neutral. Okay, true 7 values right there. And then alkaline is another term for basic. Excuse me, and that's going to be anything that is greater than 7 or from 7 to 14. Now you also again can have some values greater than 14 sort of off the charts, but we're not going to really handle any of those this year. So now like I said, with a logarithmic scale, each whole pH value, each number that it changes is 10 times difference. For example, pH 4 is 10 times more acidic than pH 5 and 100 times more acidic than a pH of 6. So you may go, oh, from 4 to 5, that's not really that big of a deal, but because it's a log-based scale, it's sort of like the similar to the Richter scale in that it will increase exponentially as you change with number values. So something to keep in mind. Okay, here are some daily household items on the pH scale. Again, here are your acidic, remember lower pHs, but these also have the highest concentration of hydrogen ion because it's indirectly related, okay? Battery acid is one of those that's off the charts. That's why batteries can be potentially dangerous. Gastric is another word for stomach acid, or gastric is another word for stomach. So here's our stomach acid, really low, which is why perforations or injuries to the intestines can be so damaging in the stomach. Lemon juice has that really sour flavor. Even carbonated beverages, some of them now they mask the sour taste, but they do have phosphoric acid in there as well, which is part of the reason that sometimes they can upset your stomach or make it feel better depending on how you're feeling. You've got vinegar, we've got pure rain, we've got milk, just to give you some ideas. Here's our distilled water, which is right at 7. Blood is definitely basic. Baking soda is basic. It's a really common base. We use it to treat acid spills for that very reason, because it can neutralize the acid very quickly. Household ammonia, in that ammonia we've talked about it being a weak base, and it's still, in the 11-12 range. Household bleach, things of milk and magnesia or Tums are basic solutions that you add to your stomach acid to try to make feel better. So again, some common ones that we should be familiar with because we're going to see them both in lecture and in lab. Now, here's the math. Now, I don't honestly know if you have these slides, so you may have to jot these down. And what you have to write down right here is this equation, okay, that pH is equal to the negative log of the hydrogen ion concentration. And you also sometimes will see hydrogen ion or hydronium. So you also will see it as the pH equals the negative log of the hydronium ion concentration. I typically fall back on hydrogen ion because that's what I learned, but you also can see hydronium as well. And essentially what happens is that the hydrogen ion is floating around in the water. It attaches itself to the water to form the hydronium ion. Okay, so that's where that comes from. But here's the equation, so you're going to have to jot this down. We're going to do a couple of math problems. You'll either need to take out a piece of paper or you can jot these down in the margins, okay? Now before we do these, you may want to go ahead and take out a scientific calculator if you have not done a lot of log base 10 problems, so you're going to want to potentially take that out. But okay, so let's see, for two examples here. Number one, what is the pH? Okay, so our unknown here, what is the pH of a solution if the hydrogen ion is 3.4 times 10 to the negative fifth molar? And we also want to know, is it acidic or basic? All right, so we're going to go ahead and write our equation down. pH is equal to the negative log of hydrogen ion. And we're going to punch this in here. pH is equal to the negative log of 3.4 times 10 to the negative fifth. So if you're looking at your calculator, you want to type in 3.4 times 10 to the negative fifth, and you're going to take the log of that. It's going to give you on your calculator negative 4.4685. Now, too many sig figs there. We only need 2. But that negative number gets canceled out by the fact that there's that negative sign out front here. So our answer is 4.5, and there is no unit on pH values. That's it. Okay, the pH is equal to 4.5. End of discussion. Now, the second part's is it acidic or basic? Well, since it is less than 7, it's going to be an acidic solution. Okay, an acidic solution. All right, now example number 2, this one, we got last one. Again, you need to write down these math problems, so if you haven't already done so, back up, rewind it, write it down. But this time, our pH is equal to 4.0, and they want to know the hydrogen ion concentration. So how do we do that? Well, pH is equal to the negative log of hydrogen ion. Now this time they give me pH. Okay, still negative log of hydrogen H plus. Now, for those of you who have not done logs before, you may go, well, how the heck am I supposed to solve that? Well, if you look above the log key on your calculator, you're going to see a button that says 10 to the x. And the way that you're going to solve that, we're going to bring this negative sign over here, and we're going to take 10 to the negative 4.0. Okay, again, you don't have to necessarily completely understand the math, but you type in negative 4 on your calculator, and you hit 10 to the x, and what you're going to end up with is 0.0001. Now we need to have 2 sig figs, so I either have to add a 0 after that, or do 1.0 times 10, 1, 2, 3 to the negative fourth, and our unit is molar hydrogen ion. Okay, so that's it. Now we'll do lots of problems in class, so I'll be able to help you with the calculator, but you need to be ready to do your scientific calculator, and make sure you ask questions in class if you need help.